Greetings, you all. I want to go over the homework. Application of congruences. I hope this was not so difficult, right? So number 16, I took the two even ones because you cannot look up your solutions here. So we have an ISBN 10 number, and it is, somebody writes this number for us, but we cannot read one of the digits, and that is this digit here. So Q doesn't stand for any particular digit. I mean, it's not like X, but it is a digit. It's a smudged digit or whatever background story you want to make here. And the question is, what was that? And that's the whole goal of showing here is that because the ISBN is set up, the check bit, which is this one, right, is set up so that you can always recover one missing digit. That's the idea of this question here. And that's interesting, of course, right? Because it does happen that you have, you might copy a number, but then you read somebody's handwriting and you cannot read that number. Or it is smudged or somehow illegible. Okay, so first of all, let's look at how does it work. So we have V4, 9 digits, right? Sorry, we have to think a little bit. So we have X1, X2, X3, X4, X5, X6, X7, X8, and X9. And then here is going to be our check bit, that is X10. And then we remember that the way it does, each of these has its own weight, namely its position, if you want. And that had to, and therefore the weight of X10 was 10, and then you took the total sum, and that has to be equivalent to 0 mod 11. But the nice thing was that 10 mod 11 is minus 1. So in other words, if you calculate the value mod 10 that you get by multiplying this with that, and add all this all up, and take reduction mod 10, then you get the bit. Okay? So let's write up what this means. But that's the way that we calculate the bit. In this particular case, it's perhaps better to just also calculate this guy and say this adds up. So if you take the sum of these, this should add equivalent to 0 mod 11. Why I do this? Because you'll see we'll have to solve something. So let's put in the actual values here. That is 0, 3, 2, 1, 5, 0, 0, Q, the one that we don't know, 1, and 8. Okay, there's no minuses, you don't get confused here, okay? So, okay, what is the result is, therefore? Okay, so, meaning I'm gonna multiply this with that, and so on, and then reduce mod 10 already, because I only have, oh no, it's mod 11, so let's not do that. Let's just write whatever it is. Okay, so this is 0, this is 6, 6, 4, 25, 0, 0, and here comes the thing, 8 times Q. We cannot know what that number is yet because we cannot read that digit. 9, and then this is 80. Okay? So now we add all this up. So what is this? If we add this up, that is 12. Well, I'm going to do this. I'm sorry. It's not so easy. If I do this 6 plus 6 plus 4 plus 25 plus 9 plus 80. So this is 130 plus 8Q is equivalent to 0 mod 11. And so this is where we have to solve a congruence relation, and we know how to do that. Well, first of all, 130 is too big a number. Well, we can reduce it, and that would be, let's see. Yeah, so if 130, we can write it as 12 times 11, because this then is, 11 times 11. That is 121, and then there's 9 remainder. So this actually is 9 plus 8Q, equivalent to 0 mod 11, and we want to find Q here. We could have put an X there, but the X would be confusing with the capital X, which actually represents a number, 10. Okay, so what do we do? Well, bring the 9 to the other side. That is minus 9, so this 8Q is equivalent to minus 9, which itself is equivalent to 2 mod 11. Okay, so now we have to find the inverse of 8 mod 11. But we can we can do this by just trial and error, right? 2 times 8, 16. 3 times 8, 24. 4 times 8, 32. 32? No. 5 times 8, 40. 6 times 8, 84. No. 7 times 8, 56. I see it. 7 times 8, that is 56, which is equivalent to 1 mod 11, because 55, this is 55 plus 1, right? And 55 is 5 times 11. So, okay, so this is, so we say 7, right? So we multiply both sides with 7, so we get, if you multiply, so I'll write it here in different colors. I multiply this with 7, and I multiply this with 7, because 7 times 8 will be equivalent to 1. So we get Q is equivalent to 14, which is the same as 3 mod 11. And therefore, that's the missing bit. So we know now that this Q was actually 3. So we can recover from this mistake. All right, so now let's look at what was the other one, number 32. So, no, number 32. So we have another type of code, the ISSN code. This is for magazines, periodicals, newspapers and stuff like that. And so there the calculation is, it's an 8-digit, so it's an 8-digit number. And so the formula is kind of, it's actually basically the same formula as for the ISBN codes. We take this, but we start, because there are less that we need, we start from 3 here. So we take 3 times this, 4 times this, 5 times this, 6 times this, 7 times, 8 times, 9 times, and we take 10 times this. And then this, if you multiply and add up, this should be equivalent to 0 mod 11. So exactly the same thing. In other words, you could think of this as following. It's an ISN number is an ISBN number, is an ISBN 10 number with the two first digits 0. And of course, if the digit, we have seen this, whenever a digit is 0, it doesn't contribute to the check bit, right? If the bit is 0, then the product is 0, so they don't contribute to the check bit. So that's the result of, you can think of this as an ISSN number as just an ISBN number where the 2 first digits are 0. And then the principle is the same, because, I mean, the book says it slightly different way. It says, okay, X8 is equal to, you calculate this, all these products and add them up, mod 11, and that is X8. But it's exactly the same what I say, because remember, 10 is minus 1. And that is just the same trick by bringing X8 to the other side. So let's do this for the particular examples that we have. So we have a couple of them, so let's do all of them. So the first one, we're doing the 32A, so this is 32A, that is 1570868. Okay, so we have to multiply this now. Oh yeah, okay. Okay, so right. So this is the multiplication. I should do this perhaps in a different color. Otherwise, this is 3. This is 20, which is the same as 9. Okay, I'm going to get my numbers small now. 5 times 7, that is 35. That is 33 plus 2, so that's actually 2. This is 0. 8 times 7. 8 times 7 is 56, but we already know that is 1. 6 times 8, that is 48. But 48, if I subtract 44, I get 4. Okay. 9 times 8 is 72. That is the 66 plus 6, so 6. Okay. And this is much easier to add now. This is 12, 14, 15, 25. So this is 25, and modulo 11. This is, so okay, I hope you understand. This is, I'm adding these. Okay, first we multiply these 2 rows, and that is the orange row. And then we add the elements in the orange row all together, and that is the result here. So here, this is the result of the, okay, I'll write it here, addition. That is the 25, but that is equivalent to, what is it, equivalent to 23, right, mod 10. So, in other words, the correct bit here is, we should have put a 3 there, okay? Let me do another one. So this is one of them. Sorry, so it's, here comes number B. That's 1, 5, 5, 3, 7, 3, 4. Okay, so again we multiply. I'll do this in orange again. So the orange is the result of this multiplication of these two rows now. That is 3, 20, that is the same as 9. 25 is the same as 22 plus 3. 3 times 6 is 18, that is 7. 7 times 7 is 49, that is 5. 8 times 3 is 24, that is 2. And 9 times 4 is 36, that is 3. Okay, if we all add them up, that is 12, 22, 32. Okay, which is the same as, oh, that's 10 mod 11. Right, it's 22 plus 10. So what's the bit here? That's the one exception here, right? Because 10, we cannot write 1, 0 because that would be two characters, 2 bits. That would make it illegible. We wouldn't know anymore which of that we would have 9 digits instead of 8. So we put an X there. So the same principle as in the ISBN case. And that's why I'm saying ISSN and ISBN are really the same thing, except that we have 2 initial zeros here. Just for completeness, I guess, so that you have record, but I don't know how much you can trust my calculations. I'm not, I told you always, that's not my forte, believe it or not, although I'm a mathematician. So we have 1089, 708. Okay, so we multiply again. 3 times 1, that is 3. 4 times 0 is 0. 5 times 8 is 40. There's a 33 plus 7, so 7. 6 times 9 is 54. 54 is, you like that? Why not? There's nothing that says I can have negative. Of course, the final answer has to be a bit, right? So we have, okay, the final answer, sorry, I'll put them in green so that you see. So the final answer was 3 here. Here the final answer was bit x. Only the final answer has to be a positive, has to be a remainder. So, okay, so 7 times 7 is 49, that is 5. 0 times 8 is 0. And 9 times 8 is 72. 72, that is 6. Okay, if I add them, 10, 9, 14, 20. And what is 20 mod 11? That is 9 mod 11. So the final bit is 9. And then we do the last one. It's 1, 3, 8, 3, 1, 8. 1, 1. 1, 3, 8, 3, 8, 1, 1. Okay. So multiply again. Remember, it's always, this is the row that we multiply. These are the weights that these things have, right? So we get 3, 12. 12 is the same as 1. 5 times 8 is 40, which is the same as 7. 6 times 3 is 18, the same as 7. 7 times 8 is 56, which is the same as 1. 8 times 1 is 8. 9 times 1 is 9, and that's it. So we get 10, 11, 18, 19, 19, 27, 36. That's equivalent to 3 mod 11. We should have done this in another color, but okay. So here the answer is 3. Okay. I might have made a mistake, but as long as the principle is clear, then. So this, of course, this is a more straightforward calculation, right? To find the bit is more straightforward. To verify that a word is correct, I didn't do an exercise, but that hopefully is also not hard. So somehow the most challenging of all problems is, okay, to correct a bit, or to fill in the missing bit. Okay. All right, that's all, and we're going to move on now to, we have moved on to cryptography already, and that's going to be, we spend much more time on that.